Well, hey guys, I visited my favorite department store today, Ray Elko, here in Salt Lake City, and I got a kick out of this. This has been there actually a while, but I thought you'd get a kick out of it. So take a closer look at this picture, and it won't take you long. You'll find out why I think it's funny. This is typical Ray Elko. It's an awesome store, great store, but they do everything their own way, and you either love it or you don't, but they're still going to do it their own way. And that's what makes it such an awesome store with so much personality. All right, I'll get to work now. Unfortunately, this umbilical from the power unit, it's pretty flexible in this trunk because I think someone replaced it years ago to take care of that bad winding in the transformer. I think they did some strange tying together inside this electrical tape. This is really old style electrical tape, so this is an old repair. They also did some funny things with capacitor repairs, so this radio was worked on. But what I'm going to do is I'm not at all happy with the brittleness of a lot of this wire, so the minute I touch any of it, hear that? So what that means to me is that insulation is cracking badly inside here. There are places where there is high voltage in here. I don't want that inside of bad insulation. I'm going to have to pull this harness out. Some of these wires I will leave in place because they're really not up against anything. Some of these shorter wires, and they go into these cans. Some of them have B+ on them. But most of them are okay, and even the ones with B+, they're not up against anything where they could short easily, so I'm not going to worry about those. But these that are all gathered together, I will worry about. So first I want to remove this clamp holding this on. Now what I will probably do is put an inline connector on this thing too, so that these things, this chassis and receiver unit, the receiver unit and the power unit could be handled separately. The way it's set up now, they're actually hardwired, and that makes it a lot of fun to try and handle, to work on one while leaving the other one alone. When you go to put, that doesn't sound like a big deal once they're already finished, the job is done, but when you go to mount these inside of a radio cabinet, it's a lot of work trying to handle two chassis. And I suppose I could solder them in after I've installed it, but why would I want to? I'll just put a connector in there and call it a day. The next person that works on this radio will thank me for it. Wow, listen to this wire. Hear that? That's why I'm doing this. It's a shame to have to remove this nice tied string. I really like that. I try to mimic it with string myself. I always get tired of horsing with electrical tape about 2/3 of the way through, and then I wind up cutting it. So I don't know why I don't just cut it to begin with. I hate electrical tape. I don't even own any. All right, look at that mess. At least they soldered it. I mean, I gotta hand it to them. They probably did this repair on a shoestring budget, or when parts were not available, or perhaps this was something done in the 70s, and parts are long gone by the 70s for this. And at that time, it was still considered an antique. So whoever did this didn't do too badly, really. And far be it for me to criticize someone else's technique. I'm still learning myself. So the detector filament winding was dead, and so what he did was he ran the RF filament winding, the leads from the RF filament winding to this location here, and then he tied both the RF and the detectors here. The rest of these wires are all original. I hate to do this, but here goes. Well, It's so cool the way they tied these. It's like a waxed string. I wouldn't know where to find something like that now. These were set up this way because they were constructed before they were installed. And then they were brought in as a harness and put in the radio, just like manufacturing is today. It's kind of cool. I mean, the way they set... Jim Linden was talking about how radio factories were set up back in the days. He's working on a 1929 radio right now too, a Victor radio. And he was talking about radio factories back in the 20s. And it's really pretty cool what they came up with back then. He was right. This was the emerging, exciting technology. And there was an awful lot going on. And we have to remember that, you know, they were motivated by the same things that factories are motivated by now. Make as much as you can for as little cost as possible and get as many out the door to customers as you can get out. It's funny, I work in manufacturing, and there's not a morning shift meeting that goes by that we don't talk about number of cases of our product made per hour or per shift and the cost per case of all those cases. It's really not ever going to change, and that's not bad. That's a good thing. It motivates us all to get better. Okay, now I can kind of see what's going on. Some of these wires, yeah, some of them are actually soft, and I'll be able to leave them. I don't know what ones were crunching, but ones that don't need to be replaced, I won't replace. But I definitely need to take care of these filament leads. It's kind of a funny thing. I loosened these wires because I thought they were making crunchy sounds. And the truth is, they're really pretty flexible. Most of them are I believe there's some solid core and some stranded in here. It's all lacquered wire, and I think what I was hearing was, you can see where the lacquer here, from when the wires were first wound together, I guess, they kind of stuck together, and what I was hearing was the sound of that lacquer kind of crinkling as it came apart. The truth of the matter is, this wire is actually in pretty darn good shape, and I had to loosen it to actually see that. And there is absolutely no reason to replace this wire. The lacquer is still sticky. I can bend the wire, and I don't get any crinkly sound, nothing. I need to pull this resistor board and check them again, and replace the ones that are bad. But really, and then I've got to take care of these caps. I already checked this first audio transformer. It's okay. I've got to check this choke over here, this detector choke, but other than that, I'm okay. What I'm doing here is I've drawn a little schematic of the resistors on this board and their layout, and I much more carefully this time measured each resistor. And you know what? They're all measuring within a very, very reasonable like tolerance of what they're supposed to be, and they all measure a little low. So that's normal if they're in circuit for them to measure a little low. So I'm pretty darn sure all these resistors are just fine. Carbon resistors, as we know, as they age or as they get used, they'll go high, they drift high, they never drift low. So the fact that these are all reading a little bit low, you know, 10 to 20% low, simply tells me that they're in circuit and we're seeing some parallel resistance effects and that sort of thing. But for the most part, what we're getting are pretty good measurements. So you know what? I'm not going to remove that board. I don't need to. I'm just going to be disturbing things I don't need to disturb. And these resistors are all within about 20%, even though I'm measuring them in circuit. So I think we're good. What that means for me is that now I do not have to lift this out of here and disturb these wires. I can actually leave these wires exactly as they are and really just repair these right here and get on to the capacitors. I'm not even going to bother to try and do any measurements of the capacitors. Capacitors are, I assume they're bad, they're always bad, and you just replace them. So I'm going to just go ahead and take them out of circuit at the capacitor block, and I'll do something neater than this, but essentially I'm going to do this. I'm going to mount them separately on the side, and we should do well with that. Once I clamp this wire harness back down, these wires aren't going to go anywhere. They're a lot tighter than wires I see in much later radios, and I don't see the need to clamp them all together. Okay, I've been doing the same thing with the terminals on this capacitor can that I did on the filter capacitors in the power unit chassis. Basically, I clean off the solder, and then you get it good and hot, and the tar will kind of bubble out. It's black tar on this. The tar will bubble out. You don't worry about that at the moment. You take this and you get this hot too, okay? And then you get it good and hot, and you shove this sucker down in there. Now be careful, because you can break this phenolic. So you just go down in there and you kind of turn it so that it doesn't get stuck, right? And you push it down in, and then you pull it out, and I wipe the tar off with a Q-tip and clean this off, and then I heat it again and do it again. Okay? Once I've done that a couple of times, I'm pretty confident that that wire is down in there. What I should have said too is, when I heated the solder and soaked the solder up with the solder wick, I took my little Xuron snippers here, and I nipped the wire right here at the base of the rivet so that it would be free to fall down in there. Alright, so I pack it down, like I said, with the drift, and then while this is still warm, I get this hot too. I get this little awl hot, and I start going down in there like this. This will go a little further down, okay? And I just sort of go around and around and around the hole. It's hard to do with the camera and the lights and everything here. I just sort of go down and down in the hole and pack it down. Make sure that wire is down in there. All right. Now once I've done that, I clean up the tar again, and then I feel like this thing is going to be, the electrical connection has been severed, and so this terminal is totally useful, so I don't have to put a terminal strip, and I can hook the wires up using the same wire dress and everything the way it was before. What I'll have to do is run capacitors because this is the ground, this is the negative, run capacitors across these three bridges here, okay? They're small capacitors, I believe. I'll have to look. I don't remember exactly, but I should be able to manage that just using these terminals and then leaving these wires connected the way they are. I got to thinking, what if the rivet goes down further than I think? And what if I'm actually not severing it? Because when I would stick the awl down in there, because of the angle, is the size of the hole, the angle, I couldn't really feel where that rivet ended, because the awl is curved, and I couldn't feel like a point at which the rivet sort of ended and stopped, and I didn't feel a bump or anything. So I have this interstage transformer that's bad, and I thought, well, what the heck, I can take that apart. It's got the same sort of terminals, same kind of rivets, same phenolic plate, everything's the same. So I opened it up and lifted this up. It's a little hard to see, and I don't want to disconnect everything, but if you look right there, you see where the rivet is. The rivet is actually fairly shallow, and so when I shoved that down, where's my drift? You guys keep hiding my stuff on me. Alright, so when I shove the drift down in there, you see, I'm actually going pretty far. I'm getting down in there pretty good. And I'm able to get that wire pretty far away. And then of course when I take the awl, I get even farther, okay? And I just shove and shove and shove, and that'll take the wire away from that rivet completely. And I'm sure that it looks similar to this guy inside, okay? So I'm pretty confident that I'm breaking that electrical connection. And one other thing I did to make sure that this kind of represented what's on that filter capacitor, I took this curved one. I can feel the edge with this thing, with this curved one. And so I went over to that filter capacitor and I did the same thing, and it felt exactly the same. and I went to that capacitor, and it felt the same too. So I'm pretty certain that this is going to be an effective method. But again, don't try this until I test it and let you know how it turns out. But I feel confident for me that it's going to work out fine. One of the nice things about this Edison is that I can remove the back panel to get to stuff that's sort of in between these capacitor cans and that panel. And I needed to install a couple of capacitors and some wires back here, so it made it real easy. So I'm replacing, this is part of, these two here are part of the umbilical, and I'm replacing, so this is going to be the B plus wire, and this is the ground wire. That'll be all new wire. I'm going to put brand new wires in for the filaments as well. I'm not going to keep that filament or that umbilical wire. I want to make it a little longer so I have room to work, and it'd be better if it's just brand new wire. Given all the problems that this radio has had with transformers, I want to protect the filament windings on the main power transformer of this radio, which I've replaced, with some fuses. So I've got a fuse set up here for the 4 filament windings that come off of the one fuse. These are the RF and the driver tube, and then the detector filament. The detector tube has its own filament winding, and that's going to come off of this fuse right here. These are 27 tubes. They're 1.75 amps is the filament current. So I will size these appropriately to give my, of course, give yourself a little headroom for surge current, but so that if those filaments short out, we don't take out filament windings. This is something that's not original, but the truth is that these transformers are probably, they're getting to be like hen's teeth, and I really don't want to, I would rather put a couple of screws in this thing that's not original than have to replace another transformer. This capacitor can right here sits right on top of the terminal board for the resistors, for a lot of the resistors in this radio, and it would not be easy to get this can off of there, and it's actually not, there are no terminals sticking out of the can to enable me to do what I've done with the other ones. So I had to cut the wires off and install capacitors outside of the can to the terminals that those wires went to. This was actually pretty easy because these are fairly small capacitors. Those are a couple of 0.1 microfarads, and then the other one is a 0.15. I'm replacing all the wires that make up the umbilical between the RF chassis and the receiver chassis. And one pair of wires are some pretty heavy wires that carry all the current for 4 tubes that come from the filament winding for those 427 tubes. And I just wanted to show you something about the wire that I picked out. And it's really good wire. It's nice, flexible, 10 gauge wire, very finely stranded wire, nicely made stuff. So check this out, guys. See what it says here? Yeah, check it out. Proudly made in the USA. Proudly made in the USA. Yeah, that's what I'm talking about. Gary, that's Rebel9668, made a suggestion in one of his comments to me on one of my vids after I did that speaker. And what Gary suggested was, hey, why don't you try putting a signal to it and see what you get? And I had thought of that, but I thought, well, it's a field coil speaker and it'd be a real pain in the keister to do that. And I don't want to risk hurting anything. But then I thought, wait a minute. All I really have to do is put the rectifier in the chassis, get high voltage to that field coil, and then go ahead and feed that audio signal. So I got my old Heathkit audio frequency generator all warmed up and ready to go. I got it set about 400 hertz, and it is connected to the voice coil of this big speaker. We have an 80 rectifier put in place, so it's ready to go, and I got the variac going. So let me mount the camera up on the tripod and let's see what we come up with, okay? By the way, I'm monitoring B plus by tapping into the bottom of that little terminal board. Okay, I've got you now where you can see what I'm doing. I've got it set up so you can see B plus. You can see the input voltage and the input current. So let's turn on the variac. All right. Let me turn on the frequency generator. Now, it will make a little bit of sound just from the frequency going through the voice coil. So, okay. Let's put in about, we'll say about 60 volts. Let's go up there slowly. I haven't done this yet. Should start to see voltage climbing slowly. Just start to lift off here. There it goes. Okay. So that's 60 volts. B plus is coming up on 10 volts. Still climbing. 70 volts input. Check it out, speaker's getting louder. Yeah. B plus climbed, peaked, and dropped back down. Alright. We're at 80 volts input, 139 volts B plus. Okay, I'll stop at 90 volts. That's good enough. At 90 volts in, we're at about 100 and, I don't know, going on 190 volts B plus. That's, I think 250 is the B plus spec. So let's turn up the frequency generator. Oh yeah. That's 10K. 2 kilohertz. 5 kilohertz. Okay, let's go back down into the hundreds. Let me go up to 100 volts. Yeah. That's working out great. At 100 volts in, 225 volts B plus. Alright, I think I've proved my point. Okay, let's turn her off. Alright, I think what I've successfully demonstrated here is that this speaker is going to work. The output transformer is going to work fine. So far, so good on the main power transformer. I tested all the no-load voltages on the windings, so we're good there. B plus is coming up just nicely. And all I did was put the rectifier in, so there's utterly no load on this thing otherwise. But it also shows me that that filter circuit is working just fine. So pretty much the preliminary tests have shown that so far so good on this, at least on this power unit chassis. That's finally a bit of good news on this radio, guys. All right, I'll get back to work on that receiver. It's making me pull my hair out over there. Okay, let me show you what I did here in this receiver chassis. I told you I was going to fuse the filament. I told you I was going to fuse the circuits for the filaments for the RF tubes and that detector tube. And there they are. The thick black wires are going to the RF tubes, and that's this fuse that's closest to us. That's probably going to be about an 8 amp fuse. That's pretty healthy. And then that one little further away from you is going to be a 3 amp fuse. That's for the detector tube. And these are 27 tubes, so they are rated at 1.75 amps steady state. So if you include surge current, I'm probably looking at about a 3 amp fuse. It'd be about the right size. Slow blow, of course. Here we go with some of the capacitors that I worked outside of the can using the terminals. And here's one here that I did the same thing. Now this little can here, there are no terminals that you can get to, and I talked about that in an earlier video, so I had to do everything sort of off of the can. Replaced all these yellow wires are the filament wires for those 27 tubes, and put new wires in for that plate right there, the green one, and then the B plus wire is another yellow wire. I wasn't thinking when I did that, and the black one, of course, is the ground. If you look closely, the way I did those 27 tube filaments is I took a terminal strip and I bent all of the terminals a little bit so that I could run a piece of heavy copper through all the terminals, and in that way was able to make a connecting point for all of the 27 tubes driving off of that fuse right there. So there's a look at it right there. Okay, let's take a look at the top side of this, okay? Okay, here's the top side of the receiver chassis. There's the umbilical that I've made. The thick black wires are those 27 tube filament. That carries the current for the 4 27 tube filaments. The green, the black, and the yellow are those B plus, ground, and plate. And the brown braided one, braided pair, is the filament, carries the filament current for the detector tube. So there's 7 wires total, and you kind of braid them to hold them together and also to try and reduce noise. There's a lot of current traveling through these, AC current traveling through these wires, and if you twist them, that helps reduce the hum that comes from them. Alright, so I'm going to get to work on this chassis. I'll polish the chassis up. I am not going to do anything with that drum other than clean it. I was originally going to take it apart, and I started, with all the luck I've had on this radio, I think it'd be smart for me to leave that one alone. If I break any of those parts or something happens to any of those parts, then I'm doomed because I have nothing to replace them with. So I'll clean it. I'll clean it all the best I can. I'll lubricate it. I'll pull these covers, I'll pull these dog houses off of the tuning capacitors, and I'll clean under there and everything. I'll lubricate. I'll deoxit the contact points and so forth. I'll spray a little deoxit into these tube sockets. I'll clean all this up, and I think that's going to be good. I'm pretty well done with the electrical work on this one too. Just a few odds and ends, and then we're ready to give her a test. Well, I kind of slept in on Saturday morning, and when I woke up, this is what I found had burrowed under the covers right next to me. You see, Fred, he likes to be close to his people, and this is what he does. So I thought you'd get a kick out of seeing this. And for now, I'm going to let you go. I'm going to close this one down. So once again, from your Western Outpost in Salt Lake City, this is Michael. That's all for now.